Uh, Welcome to the last session of the second module, which concentrates majorly on the difference between reciprocating and the centrifugal pumps, and we will also give a light on the cavitation. It is one of the major villain, I would like to say, a villain or a major problem which occurs in the pumps, and how it can be overcome, and what are the damages it can cause because of the cavitation effect. So let us discuss all those things. So this presentation contains the comparison of a reciprocating pump and centrifugal pump. It will also have a cavitation effect, causes and prevention of cavitation, priming and steps to follow to reduce the pump primings. So these are all the things we are going to discuss it in this session. We've also studied basically how this principle for centrifugal pumps works, and as well as this reciprocating pump works. So keeping that in the mind, let us go step by step. The first point is, in the centrifugal pumps, we have got a steady and even flow. That means there will be a steady flow. That means flow doesn't changes with respect to the time. There will be continuous flow. Whereas here in the reciprocating pumps, an intermittent or a pulsating flow will be there. That means the flow will changes with respect to the time. That means flow keeps changing. It will be a pulsating one, because common sense says that if a wheel is rotating, it will be rotating continuously. So as long as it is rotating continuously, the water will also be pumping continuously. As the piston moves front and it comes backwards, it moves front and it comes backwards. So now here what is happening, it is not so rigorous or continuous. And the point to be noted here, when uh, the centrifugal pumps rotates, when it rotates, impeller rotates continuously the water will be sucked. Whereas here, when the piston is moving towards the left, whether it is moving in a suction stroke, so what is happening is it is not pumping the water, it is just sucking the water. Then when the piston tries to move towards the left side, that means towards the right, towards the left, or towards the other end, then only the compression is taken place and the pressure of the fluid increases, then it will pump it. So that means out of two strokes, one and two strokes, during only one stroke, what happens, the pumps will generate the pressure. Though there are double acting reciprocating pumps are also there, but still it will be a pulsating flow. That is the reason why it is very steady in centrifugal pumps, whereas in the reciprocating pump it is not steady, it is intermittent and pulsating flow. When it comes to the centrifugal pumps, for a large amount of discharge will be done, whereas here the small discharge will be done. Centrifugal pumps can be extensively used for discharging a large amount of liquid, whereas the reciprocating pumps are used for discharging a small amount of liquids. And that also provides us one more point, that the centrifugal pumps works for the smaller heads, whereas the reciprocating pumps works for high heads. Is it clear? Can be Centrifugal pumps can be used for viscous fluids, example oils and muddy water also, and even for the sewage water and drainages water also, and even I was just talking, even the mortar is also being used. Whereas the reciprocating pumps can handle pure water or less viscous liquids. Only otherwise, the valves give frequent troubles. Now that means the viscosity is nothing but, if you take a water, its viscosity is less compared to the oil. If you take a coconut oil, it has got a lower viscosity compared to the crude oil. So these reciprocating pumps are extensively designed to operate for a lower viscosity, or viscosities with liquids with less viscosity can be handled in a better ways. its initial cost is low, the centrifugal pump, whereas the reciprocating pump has got high initial cost. And uh, reciprocating pumps can run at a high speed, can be coupled directly to the electric motor. That is how even our domestic applications of pumping water does takes place. Whereas here in the reciprocating pumps, it is of a lower speed, belt driven necessary. Belt driving is much very much necessary, and it will also have a connecting rod, crank, and all those things makes it more complicated. Whereas this reciprocating pumps is not so complicated because there is no presence of connecting rod or a crank or so much of movement is not present. Is it clear? Now here in the centrifugal pumps, low maintenance cost is incurred, whereas the periodic check-up is sufficient is enough. Whereas the high maintenance is required because the frequent replacement of parts is also necessary. It is only because this is supported by one more point, since there will be a physical contact between two solid bodies. There will be a two solid bodies will be in physical contact in reciprocating pumps. Whereas here there will not be any contact. Physical contact between two solid bodies are very much minimum, or we can say there is no contact at all. That makes the maintenance cost more for the reciprocating pumps, and it is made less for the centrifugal pumps. The centrifugal pumps, because there is no laterally or up and down movement, that is reciprocating motion is absent. So what we do it is, what is the less floor space is required because of this compact nature of centrifugal pumps. In case of the reciprocating pumps, it takes more time, more floor space, about 6 to 7 times area than the centrifugal pumps, because as we have already seen, it will have a piston movement, it will have a connecting rod, it will also have a crank, so it incurs so extra area which is required for that. Then the common sense also says if a wheel is being constantly rotating, a uniform torque is being generated. That happens in a centrifugal pumps. In the reciprocating pump, the torque which is not uniform. In the centrifugal pumps, simple constructions, less number of spare parts which are being needed. In the reciprocating pumps, complicated construction, more number of spare parts are needed. And one more point, I would like to extend this with that. Since the centrifugal pumps, in the centrifugal pumps, the liquid which is coming, which is being sucked and which is being delivered, will not come in contact with any of the material, any of the rotating elements of the centrifugal pumps. Whereas here in the reciprocating pump, what happens? The liquid which is sucking and it is been delivering will be exposed, will be in touch with the cylinder, inner surface of the cylinder, as well as the head of the piston. Is it clear? This is the one major difference, and this major difference makes its applications also different. In centrifugal pumps, it is being used in food industries also to pump the milk or the cheese and different applications. It is only because even the food which are eatables, because they will not be in contact with any of the moving parts of the centrifugal pump, so it is doesn't toxic, it doesn't spoils the quality of the food. Whereas in a reciprocating pumps, it is definitely spoils, because even for the ceilings, or it may be because of the movement of the metal parts, what we will do is we will go for lubrication, we will go for greasing of all those things that might mix with the uh, food materials, that will spoil the food. That is why the reciprocating pumps are not used in food processing industries. And one more thing is, since it can reciprocating pumps can pump even the is semi-solid also, so it is being used in various applications. Now let us talk about one of the important factor, that is cavitation. Cavitation is nothing but the Formation of bubbles or cavities in liquid are developed in areas of relatively low pressure around an impeller. The imploding, the important loading or collapsing, the imploding or the collapsing of these bubbles triggers the intense shock waves inside the pumps, causing significant damage to the impeller or the pump housings. Okay, now actually what happens here is whenever I don't have the figures over here. Now whenever the suction is been created in order to take the water from the sump, the suction which has been created, the pressure which has been created, it is good enough for the water because the water is heavier, around 1000 kg per meter cube. It is heavy. It is density is 1000 kg per meter cube. It is heavy. So in case of a leakages or in case of failure of any sealing material, or it may be failure of the foot valve, or it may be a strainer. So what happens? Air may come into the passage of suction valve or in the suction pipe. This makes the air to suck it. You just imagine the pressure with which you are sucking the water. If the same pressure is being used to suck the air bubble, then the air bubble kinetic energy will be tremendous. Its Mach number will be very high. The pressure with which the air bubble comes will be very high and it creates a shock waves. Whenever I talk about the shock waves, we always see these kind of shock waves when we launch the rockets or missiles. Got my dear friends. So much of shock waves will be created by these air bubbles, and these air bubbles will be coming with such a huge amount of kinetic energy that it will damage the metal parts of an impeller. It will damage the impeller blades itself, or it may be a casing. You might have seen it your the pumps at your home. It will have a volute casing. It will damage the metal part itself. Such a huge amount of energy that will be possessed by this. So that is what we call it as a cavitation. This will completely damage the pumps itself. Is that clear? So the proper sealing should be done for these purposes. Is it clear? Pump cavitation can cause the following problems. The failure of pump housing, destruction of the impeller or the damage of the impeller, and then excessive vibration leading to the premature seal or the bearing to fail. Excessive vibration, that is what I called you as shock waves, which creates an excessive vibrations which leads to failure of the sealings, and bearing is also being fails. Higher than necessary power consumption, that means power will be consumed more than the required power. Okay, decreased flow rate and pressure, there are chances of the decrease in the flow rate and there is a chance for the decrease in the pressure also. Okay, now the cavitation prevention. If your pumps are experiencing cavitation, check these things to troubleshoot the problem on your own. Okay, how to check this cavitation? How we can identify this? Check filters and strainers. That filters and strainers are always placed at the bottommost portion of the pipe, which has been immersed in the sump. The sump pipe, this is a suction pipe. At the end of the suction pipe, we will have a strainer and a filters. Clogs on the suction or the discharge side can cause an imbalance of pressure inside the pump. Reference the pump's curve. Use a pressure gauge and or a flow meter to understand where your pump is operating on the curves. Make sure it is running at its best efficiency point. Okay, re-evaluate pipe design. Ensure the path the liquid takes to get and from your pump is ideal for the pump's operating conditions. So then, how can you overcome this cavitation problems? Cavitation problems can be overcome with a process called priming. Then what do you mean by this priming? Priming, you might have already observed people doing this, but you are not aware that this is called as a priming. Okay. Now let me tell you what do you mean by priming. Priming is the process in which the impeller of a centrifugal pump will get fully submerged in liquid without any air trap inside. Is that clear? So this is especially required when there is a first startup. It is always advisable to start the pump only after priming. For centrifugal pump, priming is required only when the elevation of liquid in the suction tank is less than the elevation of the pump. Centrifugal pump cannot suck the liquid, but it pushes the liquid more. The liquid enters into the suction of the centrifugal pump by the energy it possesses. Atmospheric pressure in the suction potential. A pump's casing must be filled with fluid before its starting. No, actually, we have come across how we can identify that the pump's performance is being decreased by the use of cavitation, and this cavitation can be overcome by the use of the priming process. The priming process is nothing but whenever we find cavitation, it is because of the air which is being trapped in the passage. So what happens? We have to remove this air. How can we remove this air? So what we will do it is, whenever you observe whichever the pump it may be, there will be one provision will be provided at the top of this pump, where there will be a spanner or a bolt will be there. You can open it and you can go for a priming. What it does do it is, we will manually we will take the water and we will fill it. It is a fluid. If it is a oil pumping, then you have to fill the oil. If it is something else, then you have to fill the respective liquid only. If it is a water pump, what I will do it is, I will open the tap and I will open the ceiling and the bolts, and then we will fill the water into that. When this water enters into the system, it overflows. It displaces the air which has been entrapped there. So it displaces the air and it fills that place in by the water. Then suddenly it will be closed. And this process has to be done before starting the pumps. Once if you start it, it cannot be done. And while operating also it cannot be done. Please be careful. Okay, now you will replace the water by this water and we will close it. Then we will start the pump. So that what happens then, it 99% of the time, most of the time what happens, complete air will comes out and then it will be filled with water, so that there is no problem. The pump will start pumping the water continuously. This process is called as a priming. As you can see it here, no need for of priming as impeller is running in water. If the impeller itself is in the water, then no need for priming. Priming is required as impeller is running in air. Now this suction pipe is, now this is what is happening in the second case. This is how our domestic pumps are working in our homes. These pumps are placed in the air. So what happens? There may be some leakage or entrapment of the air may be possible. So that what happens? We will do it is, we will open this place at some point of above this impeller, and we will fill this completely with the water, so that the air will be displaced. Air will be taken out of this impeller or in the pump itself. So that what happens? It will be completely filled with water. Then we will start the pumps and it does works effectively. This is the idea behind of this. If not, the pump will be unable to function. If the vapor or a gas exists inside the casing, the pump will become gas bound and won't pump at all. It is something like, as I have already told you, a straw. You're drinking some juice, and if you have a straws with number of holes, what happens? The air will come inside rather than the water or a juice. So that can you suck it effectively? No, it is not. The same thing will happen for the pump also. Is that clear? If you close the holes or if you remove the air gaps, then you can suck the water or a liquid or a juice effectively. This is a small common sense. Okay, if vapor or gas exists inside the casing, the pump will become as a gas bound and won't pump. Priming is the action of filling the casing with a fluid before the startup. This is called as a priming. With an exception of self-priming pumps, no centrifugal pump should ever be started until it is fully primed. This is the first concern or care we should be taking. That is, until it has been filled with the liquid and all the air contained in the pump has been expelled, we are not supposed to start the pumps. Okay. Steps to take if pump is losing its prime. Check for leaks. 90% of all the pump's problems occurs on the suction or intake side of the pump itself. So ensure that the pipe connections threaded, threaded in to the housing are tight and that of the intake line is not cracked or has any loose or poorly glued fittings, because pipe water fittings we always glue with some gum and then we will fit it, right. Make sure that everything is tight. Then valves, and most of the time this is all happens only during the suction, only at the suction end, so enough care should be taken in the suction itself. Valves, most pumps are equipped with foot valves, that is what I just told you, which have been placed at the end of the suction pipe to keep water in the intake line and casing when the pump is not running. If your foot valve is leaking, your pump may lose its prime between starts. Replacing a faulty valve may solve the problems. That is okay. Then the obstruction. One possible reason your pump may be losing its prime is an obstruction or blockage in a line. Debris blocking the suction strain or a foot wall. Debris means it may be a dust particles, it may be a sand particle, or it may be some leaves or any sediments which are there in the water or in the liquid may come and block the strainers. The strainers are nothing but a filter, right? These debris, what they will do is they will close it. Say for example, it's a coffee filter. If it is completely filled with debris, how can we filter? It is not possible. So that also happens. So that needs to be properly cleaned. A blockage in the intake line can cause the water in the pump casing to overheat and literally boil out of the casing, causing the pump to lose the priming. So these are all the important factors to be considered while taking the pump in losing its prime. These are all the few assignment questions. Distinguish between reciprocating and centrifugal pump. What is cavitation? State the problems caused by the cavitation. What is priming? Explain the phenomena with simple sketches. What are the different steps to be followed when the pump losing its prime? This is one of the important question actually. Let us discuss a few of the MCQs. An internal cavitation in reciprocating pump occurs due to, it is obviously because of the shock waves, as I have already told you, because the air which is being entrapped in the water feels the pressure very heavy, and because of that what happens, its turbulent kinetic energy is much higher. So that makes this a shock waves to come across. It is not a drag force, it is not a cyclic force, or it is not even the flow speeds also. It is the shock waves in gases. So the answer is C. Then the formation of bubbles in an impeller is called as cavities or a cavitation. It is not called as a defect, it is not called as a friction or a heat burn, doesn't comes into picture. So itself it is nothing but the cavity. when the net positive suction head is low, it leads to, obviously, it leads to cavitation. What do you mean by breaking? Breaking is not, wear is nothing but, wear occurs whenever there's a impingement occurs actually. Then the corrosion is not at all the case. Suction head is low, then only the cavitation does occur. Lack of priming is a problem faced in centrifugal pump. Yes, it is true. Priming is very much necessary. The priming is being made to remove the cavitations. So the cavitation, the priming has to be done. If you are not doing the priming once in a often for the centrifugal pump, then it will lead to the cavitation problems. Is it clear? Lack of priming is a bigger problem with the centrifugal pumps. It is true. So the answer will be A. That is true. The last question. To avoid gas boundings, the pump is heated? No. It is elevated? No. It is primed? Yes. Is it charged? No. To avoid gas boundings or air entrapment, we always go for priming. So this will end the second module. So these are the references. You can go through different books. Elements of Mechanical Engineering by KRG. That is, even we used to study the same textbooks even in our engineering times also. So the same thing. Now it is they have made it as per the syllabus. They have condensed it as per the video syllabuses. So it is a K.R. Gopal Krishnan, and then the Elements of Mechanical Engineering by the volume 1 and 2 by Hazrat Chaudhary. It is also available. A textbook of Element of Mechanical Engineering by S. Sriyambak Murthy, who is my professor. S. Sriyambak Murthy was my professor during my undergraduation. So that is also a good book. And then we will also have one of the most beautiful book, Elements of Mechanical Engineering by R.K. Rajput. He's been a pioneer in writing the thermal books in particularly. And Ravindran, Dr. A.S. Ravindran, book of Elements of Mechanical Engineering is also a good race. So that ends the second module. Thank you.